Okay, YouTube, in this video we're going to introduce the number e, talk about where we get it from, and then we're just going to work with it a little bit as we kind of get into more exponential function based things, because we use this as a natural base. So we say often in math we use very special numbers. Some of these numbers exist like I. We know that I is the square root of -1. We just call it I in most cases, though. Just like with pi, we say that's the ratio of the circle's circumference to its diameter. But essentially this always comes out to be 3.14159 and so on and so forth. But we usually just abbreviate this with pi. What we're going to do is we're going to define this number e. And we use e to denote this number, we use a letter e to denote this number, but it is a number, okay? And we call this the natural log base e. So if anybody says, what is e? It is the natural log base, and we also call this the Euler number. And you notice how his last name, Leonhard Euler, Swiss mathematician Leonhard Euler, his last name starts with an E, so this is used, we use an E to denote his number. But basically, here's what we're going to need to know for this video. We say that E is approximately 2.718. Now, you can actually just kind of skip to the end of the video at this point, if you want to not see where this comes from, but 2.718 is only an approximation for this. This actually goes on forever and ever and is an irrational number. But Leonhard Euler, basically what he said was, he had noticed that this quantity 1 plus 1 over n, that entire quantity also to the nth power, approaches a certain number as n gets very, very large here. So for instance, if we said, n, what if n equals 10 to the first? We plug in 10 here. And essentially what we're getting is this. We get 1 over 1, 1 plus 1/10 to the 10th power. We get about 2.594. What if we were to plug in, say, 100 or 1,000 or 10,000 for these numbers right here? So essentially that's what we're going to be doing next here. And actually what I've done was I've already put this value into Desmos.com with a slider for A. And so I'm going to actually, let's make this go up to like 10,000 here. But essentially we're saying as A gets larger and larger, let's look at what the value of this quantity is doing. So if you plug in A equals 1, you start off at 2. But when we plug in, say, 100, we did 100, we got about 2.704 is what we want to look at here. So essentially, right here where we're plugging in 10 to the second, we get approximately 2.704. Now, if I pop back over to here and we say, now let's take it times 1,000. Let's go up to 1,000. We get about 2.717-ish, 2.717. So I'm going to go back 2.717 here. 2.717, and if we did 10,000, I'll just go up to 10,000 here, but essentially if we go all the way up to 10,000, we get about 2.718. You can see how this number just keeps getting closer and closer and closer to this value of 2.718. So if we were to do this on a calculator, I would tell you at this point, anything bigger than that, just out to 3 decimal places, is going to give you this about 2.718. So this 2.718 is what this approaches as n gets very large, and we just call this the natural log base. So a few things to know about the natural log base e. It is irrational. That is, it's going to go on forever and ever, as you see here, and never stop and never repeat. Okay, so 2.718281828, 459 is only a small snapshot of this number. Okay, so since we are going to be dealing with this, just like we deal with x's or pi's or i's, we're going to be using our simple rules of exponents to simplify expressions involving e. So for instance here, when I say e to the third times e to the fourth, we're going to treat this in just the same way we would do something like x to the third times x to the fourth. And recall that when you multiply two things with the same bases, you will just add their exponents. So we would just get e to the 7th here, and we could say that, yeah, e to the 7th. And as a matter of fact, what I want to do is I want to evaluate this on a calculator. So e to the 7th, you're naturally, no pun intended here, going to find your e key right around probably your ln key or your natural log key. And we haven't introduced that yet, but we say e to the power of. We could say 7, and I want to take e to the power of 7. We get about 1096.63, so 1096.63. But this is a number, but we're usually going to leave it as an exact value. We want exact. So what does this exactly equal? Now we're dividing two expressions involving e, so we say 10e to the third over 5e to the second. We would say, well, 10 divided by 5 is 2, and e to the third over e to the second, we would just go ahead and subtract our exponents since we're dividing two things with the same basis, so we would get 2e to the first. And if we wanted a decimal approximation of this, we would say, well, then we would take 1, and e to the power of that is this 2.718 times 2, and out to about 3 decimal places here. How about 2? Be about 5.44. So 5.44-ish is approximately this value. And then last but not least here, Notice that we have, and I'm going to rewrite this here, 3e to the negative 4x. Now, I have a variable value in my exponent, and we're taking all of this to the second power. So we're going to be using our property of exponents that says if you were to take a product to the power of n, you would take everything in that product, every factor in that product to the power of n. So we get 3 to the 1 to the 2 is 3 to the 1 times 2, so we get 3 squared. And then I'll say e to the negative 4x to the power of 2. We'll just multiply those. We say negative 4x times 2 is negative 8x. So to simplify this expression here, I would say that we need to evaluate this 3 squared, which is 9. And we also need to take this e to the negative 8x and put it downstairs so that our exponent becomes positive again. But this would be our simplified expression right here. So the very last thing I want to do in this video is essentially show that you can use a calculator to evaluate these things, very much the same thing we were doing here. Let's go and take a look at this. What if I took about 2.718 times itself or squared it? Again, usually most calculators behind the ln key, behind it, ours is on top of it here, you're going to have to type in e to the second power, e to the power of 2. In this calculator, we'll just type in 2 and then hit e to the power of that. We get about 7.389. So this is approximately 7.389. And just to point this out, we could also take this to a negative exponent, a very small negative exponent, and see what would happen to this. So if we did 0.06 negative, and we took e to the power of this, we get about 0.942-ish. 0.942-ish. So in our next videos, we're going to be putting this number to work to help us find some pretty essential calculations. Cheers.